was not the easiest thing ever. Unless, of course, you're talking about the ones that had x's and y's, in which case they were kind of the easiest thing ever. But the ones with just the x's, they're harder, right? So let's do so. Yes, sir? I would agree with that. Number 21. They ask you to solve each inequality by using tables or graphs. Now, that was code for use your graphing calculator, which we will try to do. Okay. If you graph this, that's a parabola, right? If you graph this, that's a line. Greater than literally means above. So we're literally going to look at the picture, and we're going to try to discover from the picture where the parabola graph is literally above, greater than, the line graph. So here is my, oh, did I close my calculator? I did. You need your calculator out. So if you don't have it, put it on top of your desk. Okay. Okay, so go to my y equals screen. I put the quadratic on the first line. X squared minus 2x minus 8. There's my parabola. There it is. Okay. Now, I could graph the second one, y equals 0, but I know exactly what that looks like anyway. That's a horizontal line. It's basically the x-axis, right? Y equals 0. It's horizontal line through there. Now, drag this over here. Visually speaking, you have to see that this region here, that's where our answers are. You see from the picture that that's the part where the parabola is below the line, right? Okay, so what we have to do is figure out how can we describe this? How can we describe this? That's what we've got to figure out. Amanda, what's up?
But didn't we both?
Oh, because I don't pay attention and have no idea what's happening.
Sorry.
Absolutely right. Thank you. Duh. The example we did in period 2 was a different one where it was a below. You're absolutely right. The above section would not be there. The above section would be right here. Thank you. Now, this, where you have an answer that's in two different pieces, you've got some answers over here going this way, you've got some answers over here going this way. Is that going to be an and situation or an or situation? Or. So I'm going to have to write my answer in two separate pieces and connect them with the word or, and then I'll be done. This area right here, this is x is greater than something. I need to know what this x value is.
4.
It looks like it's 4. We're going to confirm that in a minute, but that's what it looks like. This, or, is x is less than, because it's going to the left, starting here and then hitting this way. What does that look like?
-2.
Looks like -2. We have to check for sure, but that's what it looks like. Here's how you test. At least here's one way to do it. Go to your graphing calculator. You go to the table, so you hit second and graph and look at the table. Now, does anybody's table look completely different than this and horrible with decimals or anything like that? Yours does?
It doesn't have the third column.
Okay. Here's where, if it doesn't have the third column, that's probably because you didn't put the second equation. Okay. If you hit second and table, this first column shows the x values. Those are just things that you plug in. These y values, which graph is that coming from? The parabola or the line? The parabola, because that's what you put in for y1. So these are the y values from the parabola. These are obviously the y values from the line. That's why they're all zeros, because it's y equals 0. And so we just need to confirm, where are these values above, bigger than those values? Well, do you see how in this middle section here that these y values are less than this?
Yes.
That would be this middle part in here, which we do not want. So it looks like they tie at an x value of 4. That's this part right here. And as you go bigger than 4, as you go bigger than 4, oh, what did I do? As you go bigger than 4, all of a sudden, those values go back above. Now, if you go back the other way, oh, my table doesn't go up high enough. I can go to table settings, and I can say, please start my table at, like -8 or something, and then it'll show me. Let's see. Look at this. Do you see where they tie right here? What value is that?
Negative 2.
-2. So, what is that? Oh, I did not mean to hit that. This is -2, and this is 4. So this is your answer. This is one way to do this is by looking at the table. There is another way to do it with your calculator, which I might show you on another example. What else would you like to do? Yep,
13.
13. Is that one of the same kind?
Yeah. No.
No?
X squared.
Oh, this one's with 2 variables. Oh, these are so much easier. Well, they're supposed to be. This one says graph each inequality, and immediately you see you've got a y and an x, and you go, oh, good. So I'm going to put it on a 2-dimensional graphic coordinate plane and choose the shading. So let's use what we know, or at least try. What have we learned about this +3 on the end? It's going to take a regular old parabola, and what's it going to do with it? It's going to go up 3 units, so my vertex is going to be there. You're absolutely right.
Okay.
There's a negative sign in front of the x squared. What's that going to do?
Enlarge it by.
No, forget, not the 1/2. What's the negative sign going to do?
Flip it.
It's going to flip it upside down. Multiplying by 1/2, is that a vertical compression or stretch?
Compression.
Compression. Compression. Now, if you didn't know all that, if you didn't remember all that, you could pick up your graphing calculator and punch it in. You could do that, okay? But we have learned those types of things before. Now, I'm going to pick 0, 0 as my test point, because 0, 0 is very clearly inside the parabola, and if it works, I'll shade in there. If it doesn't work, I'll shade outside. So I pick 0, 0 and plug it in. I have 0 is greater than -1/2 times 0 squared plus 3. This goes away, of course, and I have 0 is greater than 3, which is not true, right?
Yeah.
So I'm not going to shade inside. I'm going to shade outside. And what little mistake did I make?
It's not dashed.
It's not dashed. Because look at my inequality sign. Y is greater than, greater than, greater than, greater than. So you really do need to make a dashed parabola. It is beautiful. It's a thing of beauty, really. Okay, so the 2 variable ones with an x and a y, they are easy. They're easier. You sketch them, use your calculator to help if you need to, test point and decide where to shade. We should do like one more of the other type probably. Somebody suggest one that you need.
Okay.
John. Number what? 23. Great. All right. Here again, we've got an x but no y, so we know this is going to be one of these where we need to do it the hard way. Now, the instructions say solve by using tables or graphs. Okay, so we're going to resort to our graphing calculator again. I'm going to open this thing up, and I'm going to go back and clear out my previous equations. Enter in the parabola on the first line. So x squared minus 12x plus 32. Just a quick graph on that, see what I'm dealing with there. There it is. Okay, great. Now, y equals 12. Now this might be off, that line might be a little too high. It might be off the screen a little. Okay, so 12 is up here somewhere. I can't see it. So I'm going to zoom out. Zoom out. See if I can find it. There it is. So now here's what I'm dealing with, okay? I would like to know, John and people, where the parabola is below the line, right? Because it's less than, okay? This time I do have it right. That's the part that's below the line. Is my final answer, John, can you tell just by looking at it, this is an in-between kind of thing, is my final answer going to be an and situation or an or situation? You know? Anybody know? What? It's going to be and. Anytime you have an in-between, It's going to be x is less than this and greater than this. It's an in-between situation. It's not or. Now, I'm not going to use the table on my calculator this time. I'm going to use something else that you might find helpful. I would really like my calculator to find the x values where these graphs touch there. I would like to know where that occurs. It looks like maybe 1 and then, I don't know, 8 or something. But I'd like to know. Second and trace. Look at choice number 5 if you go to second and trace. We have done this before with something else. You'll see it's the word intersect. It will find where two graphs intersect for you. So I'm going to hit that, hit enter, and it'll say, hey, first curve. It's on the parabola. That's good. So enter. Second curve, it's on the straight line. Yes. It wants a guess, so I'm going to move the cursor over to there, hit enter. What x value does it touch at? 2. It's got a little blinking point right there, x equals 2. So I'm going to go, oh, this guy right here, that's an x value of 2. And now I need to find the other one. Now I need to find the other one in the same line. Second trace, intersect. First curve, parabola, sure. Second curve, line. Please give me that point. 10. 10. It is so interesting. Now all you have to do is figure out how to write your final answer. The parabola is below the line in between those two x values. So my answers are all the values that are in between that are less than 10 but bigger than 2. That's my answer. What are we saying? We're like, hey, as long as x is in between 2 and 10, we're good. This, by the way, we're recording this period. Hi. This little procedure right here, this would be a good, if you were going to go back and review something, let's say, this would be a good candidate for something like that. Would you like to do anything else? We should. There's one we should do. We should do,
26.
yes, yes, 26. We should do 26. Now the instructions here, guys, are solve each inequality by using algebra. Now, could you solve this inequality in exactly the way we just did?
Yeah.
Absolutely you could. Absolutely you could. But they have requested another method. And we might do this same problem 2 ways just to see how it matches up. But they've requested that we use algebra. So we need to understand what that means. That means you start off by going x squared minus 5x, add the 9 over here, so that's looks like plus 5, and you use the related equation. You temporarily treat it as if it were an equation. You worry about the inequality in a minute. This does not factor, right? Nothing multiplies for 5 and also adds for minus 5. So you immediately have to go to the quadratic formula. A is 1, B is minus 5, C is 5. Okay. Working this out, we've done this a lot. X is minus b plus or minus the square root of b squared minus 4 times a times c all over 2a. All right? Now, simplifying this just a little, this makes a plus, 5 plus or minus. This is a 2. Okay, that's 25. 4 times that's 20, and only one negative sign, so there's a square root of 5 in there. Now, come on, little board. Let's go. Don't lock on me, please. Yeah, they are. It's not happy. Did you hear that static snap when I touched the control? That's when you touch this thing, you just accumulate static, and then it's not happy about that. Okay. These are ugly irrational numbers, right?
Yes.
How many of them do you see here? You see 2 because there's a plus or minus. 2 because there's a plus or minus. So there's one with a plus, one with a minus. Now, I can write them separate if I want to. x is equal to, I'll write the plus one first, 5 plus the square root of 5 over 2, and then there's one with the minus, 5 minus the square root of 5 over 2. Our final answer, guys, because it is an inequality, is going to require the use of a number line. Do you have any idea where this ugly number and this ugly number belong on the number line?
Imaginary.
No, they're not imaginary. There's no square roots of negative numbers here, Shane. This is not the square root of negative 5.
I thought it was a negative.
No.
Square root of 5, but I was mistaken.
Wait a minute. It is a negative square root of 5. It's not the square root of negative 5, which is a whole different thing. Okay. There's nothing wrong with these, but I don't really know off the top of my head where these belong on the number line. So, in order to help me locate these points, which will chop up my graph into the intervals that I want, I will pick up my calculator, and I will put these in and get a decimal, rounding for them. Why am I doing this? Because I'd like to know where they belong in a number line. So the first one is parentheses 5 plus the square root of 5 divided by 2. Okay? About 3.6. The next one is the exact same value except with a minus. About 1.4. Okay, so 3.6 and 1.4. 3.6 approximately and 1.4 approximately. Now those numbers I can locate. 0, 1, 2, 3, 4, 5. 0, 1, 2, 3, 4, 5. This guy goes here. This guy goes here. Am I correct to leave open circles?
Yes.
Yes, I am, because it's a less than sign, not a less than. My graph has now been chopped up. My number line has now been chopped up into 1, 2, 3 intervals. We only have to check one test point. Which test point would you like to pick? I don't want to pick 2. I want to pick 0. I always want to pick 0 because it's easy. What's the only time when you couldn't pick 0, do you think, as a test point? When one of your dots is actually on 0. Then you're like, oh, shoot, can't use 0 as a test point. But if 0 is not one of your actual points, I always pick it because it's, it's easier. So I'm going to go back up here, and my original problem was x squared minus 5x minus 4 is less than negative 9. X squared minus 5x minus 4 is less than negative 9. And I'm going to plug in 0 as a test point. So 0 squared minus 5 times 0 minus 4 is less than negative 9. Goes away, goes away. Negative 4 is less than negative 9. No! So this area does not contain any answers. Therefore, what other area will not contain any answers?
The other
side of.
Right, because you will always either get both outside regions, or you will just get the middle region, not some weird combination of those. So if this outside region didn't work, neither will this one. Therefore, my answers, oops, red would be nice. My answers are right here. How do I write that? I write that like this. Let me move this out of the way so I have room to write it. I can write x is in between. Now I have a choice. I could write the decimal numbers that I rounded off. Or if you're feeling extra fancy, what could you do?
Right, the 5 plus square root of 5 over 2.
Write them in their true, exact irrational form. This is the one with the plus. 5 plus square root of 5 over 2. 5 plus the square root of 5 over 2. I could separate that if I wanted to. 5 minus the square root of 5 over 2. You could write your answer in either form. Now, do you have your graphing calculators in your hand?
Yeah.
Everybody do this right now. Take your graphing calculator, go to the y equals screen, clear everything out of there, put the parabola in as the first equation, and put the line minus 9 as the second equation. X squared minus 5x minus 4, and then minus 9. And hit zoom 6, give a nice standard zoom. We should be looking at the same picture together. What's up?
I didn't get it.
What do you get? Oh, you paused to see the little dots. That is the worst feature ever. while your calculator is graphing, if you hit enter, watch, if I hit zoom 6 while it's graphing, see, it wouldn't even. Okay, see how it stopped and see the little thinking dots here? You're like, what the heck happened? You paused it by hitting enter again and unpause it. It's so, all that does is confuse people who don't know why their calculator froze. It's totally useless. Now, this picture right here. Where is the parabola below the line? The little tiny space right down here. See that? On your own, right now, just to make sure that you can do it, can you please use the second trace intersect thing to find those two x values? Please, right now. You should find that they are the same x values that we got here, 3.6 and 1.4. That's what we're checking for. 3.6 and 1.4. If you got it correct and the person next to you looks like they're going to cry, help them. Please, help them. On the graph, when you're graphing, do you shade it in and you outline it like answer? Just outline it like I do. Because remember, this is a one variable problem. We're only using the graph as a tool to help us figure this out. So I would never, for a problem like this, for instance, do something like this or whatever. Is that what you're asking me about? No. My final answer doesn't even involve a two-dimensional XY graph. We're just using that as sort of a tool, as a bridge to help us figure this out. You were just tracing right, weren't you? Second trace. Choice 5, intersect. There you go. Do it again, do it except this time. It works. Second trace. Choice 5. First curve, second curve. You move your cursor down here for your guess. If you move it a little closer to the intersection point on the left, you get the 1.4 answer. And if you move it a little closer to the intersection point on the right, you get the 3.6 as your answer. And you have to then know, oh, it's in between those two. And you take those two values and write your final answer just like we did. What do you think is easier? Do you think it's easier to do it like this or easier to do it with algebra?
Calculator.
There's usually disagreement, but at least some people always think it's easier to do it on your calculator. If I'm working this out on my own, if I'm making a key for a test or whatever, I always do this on my calculator. I don't need to do the quadratic formula again for fun. If you're comfortable visually, parabola below the line, that's right here, and you use the second trace function, second trace and intersect, it's pretty darn fast. I know. Okay. I need to check this assignment still, but put it away just for now. Keep your calculator out on your desk. Keep it. We saw the word regression in chapter 1, except we called it linear regression. Do you have any recollection as to what we were doing when we used that term? We had a graph, and there would be a scatter plot. And if we did linear regression, we got this, which is a
Line of best fit.
line of best fit. This is just a fancy word for, well, we kind of cheated in chapter 1. It's not just necessarily a line of best fit. It could also be a parabola that best fits the data, because not all data can be described very well with a straight line. Almost all of this section is going to be done on your calculator. So yeah. Now, I want you to look at something. Don't bother to write this next part down. Let me erase this here. I just want you to see it and understand what I'm saying and not worry about getting lost in the details. If you're just looking at two relationships, here's some x's and y's that go together, here's a function, here's another function. How can you tell whether something's a regular old straight line or whether it's going to make a parabola without bothering to graph it? You need to understand this. Here's how you can tell. First thing you have to check. Going up 1, up 1, up 1, plus 1, plus 1, plus 1, plus 1 every time. You have to start off with x values that are evenly spaced x values. If your x values jump all over the place, 2, 300, negative 12 and a half, and we're about to look at the y values that go with it, and it's not going to be helpful to analyze it. So your x values, whatever they're doing, have to be consistent, evenly spaced. Now, you look at the y values. Plus 4. They all go up by 4. In Algebra 1, you said that these were constant, and the vocab word was first differences. Meaning you only had to check one level down to already see that they're changing by the same thing every time. Bless you. If this happens, you know what kind of relationship this is? Makes a line. If every time, if you put the change in y over the change in x, you see how it would be the same every time? That's called the constant slope. So this would be linear. Now, this next one is going to be quadratic. Number 1, do we have consistent, evenly spaced x values? Yes, we do. Now, just based on your pattern observation and being math students for a while, how many levels down do you think we're going to have to go before we see something staying constant? If this was linear, that's x to the 1. This is quadratic, that's x to the 2. Going from 12 to 10, that's minus 2. Going from 10 to 9, that's minus 1. Going from 9 to 9, that's minus 0. Going from 9 to 10, that's plus 1. Those aren't constant, so is this linear? No. So we have to go a second level down. From minus 2 to minus 1, that's plus 1, plus 1, plus 1. Oh. Those are constant second differences. If you go 2 levels down to find them remaining constant, that's a quadratic. That's how you tell. That's how you tell. So you don't have to bother graphing them all to see if they make a parabola. That's what you check. Okay. Now, what are you actually going to do with any of this information? You're going to do stuff like this. Back to the original. The table shows the cost of circular plastic weighting pools based on the pool's diameter. Those little pools are like this high. You're going to take your calculator, you're going to go to the y equals screen, and you're going to clear anything that might be there because we don't want any graphs left over from our old stuff. We have been through all of these steps before, but it's been a while. Stat and edit. We would like to put what are going to be our x values, the diameter of the pool, in the first column, L1. Make sure you have an L1 and an L2. And if there's data in there, you need to delete it. You need to clear it. See 4, 5, 6, 7. And then slide over to L2 and put the y's in there. 19, 95, 20, 25, $25 even, and then 34 minute. If your lists are missing or messed up, it'll help you for the next few after. And we'll get back to it. What are we going to do now? Now, how do we display this? Scatter plot. You can do graph, not going to be there. Second y equals, you got to turn a scatter plot on. Turn it on. Hit graph, I see nothing because I need the correct zoom. Do you remember the correct zoom? Zoom stat, which is choice number 9. Zoom stat, which is choice number 9. So you see this. Now, based on the data, you could see kind of a line going through there that wouldn't be a horrible estimation, but it does look like it would make a much better product. Okay, so here's how you calculate it. Stat. Slide over to the calculate menu. Go down to, now in chapter 1 we use choice 4, which is linear regression. Please find the line, the linear equation that best fits the data. You're just going to go to choice 5 is all. And ask it, please find the quadratic equation that best fits the data. Degree 2, right? Quadratic, x squared. So hit enter once or twice to get it to execute the command, and look at what we have. This is nice. We have in y equals ax squared plus bx plus c form, here's a, b, and c. Y equals a is 2.4x squared minus 21.6x plus c is 67.6. I'm rounding to the nearest tenth. Make sure you can get this. If your calculator gives you something that's close but just slightly off, you probably misentered one of the data pieces just by a little bit. Yeah. Some of you might have the R data on your screen still. That's fine. Get the cost. Yes, we do. We'll go to. Stat. There it is. How's your scatter plot on? So let's turn the second one equals. Your scatter plot on. Zoom 9. Your scatter plot. It told me. I mean, I'm rounding. They gave me 2.4125. Well, I'm rounding to the nearest tenth, but they did it for me. Now, some of you have the new fancy update to your operating system, and it gave you an extra screen in there while you're doing this. You just keep hitting enter until it calculates the correct equation for you. Now, would you like to see this equation on that graph?
Sure.
I would like to see that equation on that graph. Here's how you do it. Hit second and mode to quit, hit clear, get a blank screen to start from. So that we're all on the same page. Now, very similar steps. Stat, slide over to calculate, go down to choice 5, but only hit enter one time. Once. Now, if you have the older operating system like I do, which I actually prefer, this is what you see. Some of you have the newer operating system, in which case you see a screen right now that looks like this. You see it says X list 1. Hey, where are my X's coming from? List 1, so where we put them. Y list L2. Then it says frequency list, nothing there. Now the next one's important. It says store reg EQ, right? Right? Does anybody see this? Is that Doc? Are you the only one? You do? Okay. if your calculator is displaying the screen for you, you want to move it, so you want to use the arrows to move your cursor down in front of the store regq. Store means, hey, when we calculate this, where would you like us to store? Where would you like us to put the regression equation, the quadratic that we calculate? So you put the cursor right there. For the rest of you, for the rest of us, you do this. Variables, variables key. Is it familiar? You know where to go? Y variables, function, and the very first one, y1. Now hit enter. It will recalculate it for you. Nice. And if you hit graph, you will have that. Make sure you can do this.
Yep. Did you just press y equals, the button y equals, and then change it up? I mean, no.
You can't. That doesn't
Like
work.
with a line. Like instead of the dot, you pick the line.
It won't enter an equation in there. So it's not as useful.
Yeah.
If you've got it figured out, help somebody who doesn't.
Drain, you got it? Got it good? Mine comes colored.
Shut up, don't laugh
Yes, I know their players. It's the same as it was last year. Except they added what's his face from Barca.
Hey, help somebody. Don't talk about that right now. Help somebody else.
I hope they're. Yeah, you had it.
Yeah.
4 years, but they're offset by 2.
Except he hasn't been saying now.
So every 2 years you have
This class, I don't know why.
Look, he's recording. Late to camera.
My favorite player is
All right, ladies and gentlemen, attention up here for one more second. I'll come up here in 1 second, Gary. Up here, please.
I thought that was the camera.
Up here, up here, up here. Obviously, even though this is the second time this year that we've gone through steps like this, this is something that you probably need to go back over and review. You can then use this equation to find all kinds of things. They said, hey, use the model, the equation that we came up with, to estimate the cost of a pool with a diameter of 8 feet. That is an x value. So you would go to your graph, and you'd go second, trace, and value, and you'd enter in 8, and it would tell you you're invalid. Now, why would it do that? Probably because I just have to zoom out a little to make sure that the value I requested is on my screen. And I'll zoom out. I'll try it again. Second trace, value, enter in an x value of 8. And the y value that goes with that is $49.537 or $49.54 according to this. We did this all in chapter 1, but it's been a while. Okay? Your homework is as follows. Need to make a slide adjustment here. Test review tomorrow. Test will end up being Tuesday. Quiz corrections are not till tomorrow. There is your homework. And I did upload a video helping you with a particular problem on there, which you may want to